Okie dokie, part 3 of chapter 4, tissues. Let's get right into it. So, adipose tissue is made up mostly of adipocytes. Adipo meaning fat, cyte meaning cell. Okay? Their nucleus is pretty much pushed off to the side, wherever it may be. It gets pushed off to the side because the inside of it is full of fat droplets. Okay? These tissues are highly vascularized, so they grow pretty well. They're really easy to heal. They're usually no big deal. Okay? The function of adipose tissue is to provide reserve food fuel, so they store energy, as well as insulate and cushion your body. So it insulates against heat loss and supports and protects your organs. Okay? You will find adipose tissue pretty much anywhere else that you would also find areolar connective tissue. But you'll find them in particular just under the skin, particularly around your kidneys, behind and around your eyes, within the abdomen and the breasts, and within the hypodermis. Okay? There are two different types of fat cells, or fat tissue, or adipose tissue. I apologize. There is white fat cells and brown fat cells, but you mainly only see brown fat cells in infants. Okay? So, like I said, as I was kind of drawing that, you see all of these fat droplets within the cell, and the nucleus gets kind of pushed off to the side there. Okay? They have a very sparse matrix, so they don't have a ton of extracellular matrix. Okay? Because they really don't need it. Those fat cells take up a lot of space on their own. Like I said, the other type was brown adipose tissue. That one produces a lot of heat. They aid in a lot of thermoregulation. There is a little bit in adults, but mainly you're going to find that in babies. Okay? Highly vascularized, contain lots of lipid droplets, and lots of mitochondria. They need a lot of mitochondria because a lot of the times they need to break down that fat for it to produce energy. So if you're angry about some excess fat around your body, don't be. Your body needs it for energy and it needs it for a good cushion. If you fall and you hit your, like when you hit your funny bone, you're hitting a nerve. So if you had more fat around your elbows, you probably wouldn't hit your funny bone as much. Things to think about. Okay, last type of proper connective tissue is reticular connective tissue. If you can imagine, it is mostly just reticular fibers. Those reticular fibers are made of collagen, but they are in a net-like structure or formation. Okay? This reticular connective tissue aids or functions as kind of a scaffolding for your soft organs. So they help kind of make up the shape of some of your softer organs, like your liver, like your spleen, your pancreas. That's a pancreas. Sorry. All of those need some structure, so the structure is formed by that reticular connective tissue. This is kind of an image of that reticular connective tissue. You have these reticular fibers. Let's choose a different color so they're a little bit brighter to see. Those reticular fibers are a little bit more branching, a little bit more net-like, as opposed to our collagen fibers that are just kind of straight like that. Okay? So moving into the dense connective tissue, because we talked about how our the two main groups, right? And you have we're actually just going to do proper here, and proper breaks into loose and dense. And if you can imagine, the biggest difference between loose and dense is how well or tightly packed the tissues and fibers are. In loose, they're kind of loosey-goosey, a little spaghetti-like, and in dense, they're a lot more structured. Okay? There are three types of dense connective tissue: dense irregular, dense regular, and elastic. Okay? So they have some strong pulling force resistance, so they can handle a little bit of pull, a little bit of wear and tear. Not really wear and tear, but a little bit of pull for sure. And they have a lot more collagen than those areolar connective tissues. All right. So, dense irregular tissue. Those collagen fibers are very thick, but they're not arranged in any sort of pattern. They have a lot of random arrangement. Dense irregular connective tissue has some elastic fibers here and there, but it's mainly those thicker collagen fibers, and it does also contain some fibroblasts, and that fibroblast helps to make up that ground substance. Okay? This irregularity in the patterning allows for movement in many different directions. When you're pulling, right? So you have that density, but they're not super organized or anything like that. But it is really dense in there. Okay? It's not as strong as dense regular connective tissue, but we'll talk about that when we get to the regular connective tissue. Okay? You'll usually find, well, we'll talk about that on the next slide. So its main job is to withstand tension. Like I was saying, it can be pulled in several different directions because those fibers are not necessarily parallel to one another. So they can be pulled in a lot of different directions. But because of that multi-directional pull, it's not as strong as it could be. All right? But it does provide a good amount of structural strength. You'll find it in the underlayer of the skin called the dermis. Okay, so you have your epidermis, and then your dermis sits below that. And we'll get into those different layers of skin when we talk about the integumentary system. Okay, you'll find it in the submucosa of your digestive tract, and some of the fibrous capsules of your joints, and in some of the places surrounding your kidneys and your bones and your lymph nodes. Okay, so they kind of wrap around your joints, organs, and some bones. All right. So as you can see, these collagen fibers, they're not exactly organized. They're kind of just all over the place. They're organized however they want to be so that you can move your skin in 15 billion different directions. Okay? They allow for, you can see here in this shoulder joint, your shoulder can move in a whole big circle, right? Your shoulder isn't necessarily made up only of these connective tissue. Well, it is a lot of connective tissue, but this allows for kind of that movement all over the place, right? Because they're not as regularly organized as our dense connective tissue. When we get into our dense, regular connective tissue, the patterning of those fibers is very, very regular. They are very parallel to one another. This means that when they move and when they stretch, they kind of only go in one direction, like in a pulling sort of direction. All right? They have great tensile strength, but they're not very vascularized. So if you rip some of your dense, regular connective tissue, it's going to take a lot longer to heal. Okay? It has a few elastic fibers here and there, but it's mainly just those collagen fibers and fibroblasts. All right? They also form the fascia. The fascia is what wraps around your muscles. Okay? They also help form your ligaments and your tendons. I guess we're not writing ligaments right here. Okay? Your ligaments help connect bone to bone. And your tendons connect muscles to bone or bones to muscles. Okay? Like I said, your tendons and ligaments attach your muscles and bones to each other. They can withstand great stress in one direction. That's because those fibers are parallel. And like I said, it forms your tendons, your ligaments. Aponeuroses are just another fancy word for joints. And the fascia that surrounds your muscles. And that's just kind of like a little sack. Okay? But they can handle a lot of stress and tension in one direction. Okay? So, like I'm saying here, as opposed to our irregular connective tissue, they are very, very straight. They're very parallel. Yeah, you see a little bit of wave in there, but that's not, well, that wave allows for a little bit of flexibility. They are strong, but that does not necessarily mean that they are stiff. Okay? So the last of our connective tissues, the last of our dense connective tissues, I guess, are the elastic ones. Those ones, if you could have guessed it, have a lot of elastic fibers. If we remember correctly, those elastic fibers are very wavy. They allow for movement. They allow for recoil. Things get to stretch and then come back. All right? You'll find those mainly in walls of arteries, in some of the ligaments, some of them, and surrounding your bronchial tubes. You're going to need that connective tissue to expand and contract while you breathe so that your lungs can fill up and take up space. So you need that elastic connective tissue to recoil, to stretch and recoil properly. You'll note that those elastic fibers, they're very, very wavy. Let's do yellow. Very, very wavy up in there. Not so much like our collagen fibers that are very straight. Not even so much as our irregular that are all over the place. These are very, very organized, but very stretchy. All right. So that finishes up our connective tissue proper. Now we're going to move into some of the specialized connective tissues. The first of which is cartilage. All cartilages have similar structural components. There are 3 types of cartilage. That's the wrong color. There is hyaline cartilage. There is elastic cartilage. And there's fibrocartilage. The main cell types of cartilage are going to be your chondrocytes. It says that right there. Main cell type. Okay? Chondrocytes are the mature cells. Chondroblasts are immature. Gosh, doesn't want me to be great. Okay, sorry. So your chondrocytes are mature and they basically do maintenance. And your chondroblasts are the ones that are doing most of the growing and secretion of their proteins and whatnot into that extracellular matrix. So those chondroblasts are doing that. All right? There are no blood vessels and no nerves in your chondrocyte or in your cartilage. You don't really need them. The problem with that is that makes them incredibly difficult to heal because they don't have any blood or nutrients going directly to them. They have to kind of leach it from the tissues around them. Okay? So they're a lot harder to heal. Like I said, there are 3 types: hyaline, elastic, and fibrocartilage, and we're going to talk about all of them in a little bit more detail. They all have special functions, and they all do their own thing. There is a term that you might want to note: perichondrium. If you break up our Latin roots a little bit, peri means around. Chondri or chondro is cartilage. So some types of cartilage will have this perichondrium around it. Okay. So hyaline cartilage have relatively thin bundles of of collagen fibers. They're so thin that they're almost impossible to see, but they give that hyaline cartilage kind of a glassy, bluish white kind of appearance to them if you look at them under a microscope. Okay? We'll talk about its function in just a second. I don't want to get too far ahead of myself. But like I was saying, those chondroblasts produce the matrix. So they do the secretion. And the chondrocytes are your mature cartilage cells that do maintenance. I think that's how you spell maintenance. And they lie within what is called a lacunae. Lacunae are basically just little holes for them to hang out in, and you'll see them kind of like this. You'll also note that you'll see lacunae in bones as well. Okay? So the function of that hyaline cartilage, like I was saying, it helps to reduce friction between bones. It is strong and flexible and does a lot of support. It is a precursor to bone in fetuses. Precursor to bone in fetus. Because we know that a fetus's bones don't fully, they form, but they're not all like hardened skeletal bone right out the womb. So their precursor is that hyaline cartilage. Okay? So they do a lot of structural support, they reduce a lot of friction, and they resist a lot of repetitive stress. That's that reducing friction. They are pretty resilient, and they do a little bit of cushioning in the places that you'll find them, such as, come on, it's taking its sweet time to move on to the next slide. Sorry if you guys are hearing all of this. Locations such as, I don't know if I'm repeating myself, I'm sorry, it froze on me, but like I said, you'll find them in the fetal skeleton. You'll find them at the distal end of long bones. So if you have a long bone, such as your femur, that is the ugliest femur I've ever drawn in my life. You might find some hyaline cartilage right down here at the end, at the ends of them. Okay? So you'll see that hyaline cartilage in your ribs, in your nose, in your trachea, in your larynx, the like floppy part of your nose that before you hit the bone part, that is hyaline cartilage. And then this image is kind of just showing you that breakdown again. So you have your matrix. That matrix is made by which cells? Right, your chondroblasts. Chondroblasts. Sorry guys, I've been talking to myself for a long time here. My bad. And they are housed in lacunae. The single of lacunae is lacuna. But these are the lacuna. And these are your little chondrocytes hanging out. All right. Next up on our list is elastic cartilage. Elastic cartilage is very similar to hyaline cartilage, but instead of having collagen be its makeup, it's a lot more elastic fibers. Okay. They maintain their shape, but they have a lot of flexibility to them. You'll find elastic cartilage in places like your ear. That's why you can kind of fold your ear into teeny tiny little pieces, not like little pieces, but you can fold your ear, you can close it off. That is elastic cartilage, and it has that ability to recoil as necessary. Another place that you're going to find that is your epiglottis. Your epiglottis kind of sits in the back of your throat, and it is a little flap that prevents your food from going down into your lungs and your air from going into your stomach. Okay? This is flap in throat. So you don't choke. And we need something like that to be elastic, because if it gets stuck, then we are stuck and you will choke. Okay? So, see those elastic fibers all up in there? You can't see what I'm drawing. There you go. So you see those elastic fibers, they're pretty willy-nilly, pretty wavy, but you can also see those lacunae, that chondrocytes. All right. And the last cartilage on our list is fibrocartilage. Fibrocartilage is, you can think of as a blend of hyaline cartilage and dense regular connective tissue. Dense regular. If those two had a baby, it would be fibrocartilage. Okay? Fibrocartilage is one of the only ones that do not have that perichondrium. Ah, that's so annoying. But they have a lot of fibroblasts. Hence the name fibrocartilage. Okay? They have very dense collagen fibers, very similar to dense regular connective tissue, but not a lot of ground substance. It is very strong. Your fibrocartilage is very strong, and it is able to resist compression and tension. So it can handle a good push. Anyways, they can handle a good push and a good pull. All right. They take nutrients from the surrounding tissue because, again, this cartilage is not very vascular. But they do what we need them to do. You'll find fibrocartilage in places like your intervertebral discs. So in between the bones of your spine, you have that fibrocartilage. That's what allows you to jump and run and put any kind of pressure on your spine. Okay? You'll also find that in your pubic symphysis. That's a bone that we'll talk about. Your pelvic bone has a little piece of cartilage right in the middle that keeps everything together. And then the discs of your knee joints. So like the bursa around, kind of surrounding the bursa of your knee joints. And you can see that fibrocartilage looks a lot like our dense connective or dense regular connective tissue. Okay. So you see those collagen fibers, they have a little bit of a wave to them, but they're mostly straight. And they only have that little bit of wave so that they can handle a little bit of pull and push. But mostly you'll see those chondrocytes hanging out in those lacunae. Just like that. Okay? So that wraps up our cartilage, one of our 3 types of specialized connective tissues. The next one on our list is bones. Bone, also known as osseous tissue. Has a rock-like hardness to it. It is incredibly, incredibly strong. If you were to look at kind of the density, I guess, or the strength of the ground substance of the different connective tissues, you'd see on one side with rock-like hardness that is basically solid, bones, then cartilage, your connective tissue proper would be somewhere in here, in varying forms. And then blood. Because blood is a liquid, and we know that. So that bone matrix is made up of an organic and an inorganic part. The inorganic part is comprised of, that inorganic part is comprised of these calcium salts, and the organic part is made of collagen fibers. Okay? The cell types within our bone tissue are osteoblasts and osteocytes. And just like everything else that we've talked about, the blast cell secretes those collagen fibers and that ground substance to make that extracellular matrix. And the osteocytes, the site cells, are the mature bone cells that do maintenance. I think I've spelled maintenance differently every time I've written it. Your bones, surprisingly, are incredibly well vascularized. There is essentially a tube of blood vessels that goes straight through all of your bones. So when you break a bone, I'm not going to say it's easy to heal a broken bone, but it's easier than healing like a ligament tear or something like that, at least on a microscopic level. Okay? Oh, side note, another type of bone cell is an osteoclast. And osteoclasts break down bone. And you need to break bone down for several reasons that we'll talk about when we get more into the skeletal system. Okay? So, the main functions of this bone tissue, this osseous tissue, is to support and protect your organs. It provides levers and attachments for muscles. Your muscles couldn't move if they were just contracting against each other. They would just pull each other all the time. So they have to have something to grab onto so that they can do that kind of muscle movement. They store calcium, minerals, other fats, and the marrow of your bone is actually where your blood cells are formed. Okay? And the location of all of this bone tissue is obviously going to be right there in your bones. Osteoblasts, osteocytes, they also are housed in lacunae. So you're never really going to get away from those lacunae. Okay? So this central canal here, let's draw that in a different color. This central canal here is where the blood passes through. Okay? The lacunae, let's do purple, are these big circular bits and pieces here. Okay? Your bone is essentially just calcified cells that are really, really hard. And they do a good job of protecting and supporting your entire frame so that you can be upright and move. Alrighty, the last of our specialized connective tissue is the last one that you would ever think of, and it is the blood. Blood is technically a liquid tissue that connects all of the tissues. And you don't even really ever think of tissue as being liquid, but it is. It, like all of the other connective tissues, is developed mesenchyme in the embryo and consists of cells that are surrounded in a non-living matrix. That non-living matrix is very similar to our extracellular matrix, but in the case of blood, we call it plasma. It's that like whitish, clearish stuff that comes out of your like skin after if you have a scab and you pick at it and then you squeeze that scab a little bit, you'll see what we call plasma. Okay? So, blood tissue is essentially just red and white blood cells hanging out in a fluid matrix. Its main job is to transport gases, nutrients, waste, and all kinds of other dissolved molecules. And your blood is literally everywhere in your body, except for the places that are avascularized, but that's a different story entirely. Red blood cells are also known as erythrocytes. That's just a fun and fancy way of saying red blood cell. And white blood cells, which are called leukocytes. White blood cells. The root that you're going to need to know for those are leuko. Leuko means white. Erythro means red. Like I've said many times before, biologists are not exactly clever. And you're going to find blood within your blood vessels. That's probably where it should be. There's one more important cell type of the blood tissue, and those are going to be thrombocytes. And thrombocytes are basically just small cell fragments that are used in blood clotting. They're also called platelets. If you've seen Cells at Work, the little platelets are my absolute favorite. If you haven't seen Cells at Work, go watch Cells at Work. All right, so like I was saying, kind of blood hanging out in its fluid matrix, which is very similar to the extracellular matrix of all the other tissues, but in this case it's plasma, transporting gases, other substances, waste, nutrients, our red blood cells, we got our white blood cells, we got some platelets here and there, and there's like 5 main different types of white blood cells, but we'll get into that when we get there to that chapter. Okay? These are just different, the next 3 slides, I think, are just kind of a graph of showing you where and what the different connective tissue types are, because we have now, at this point, gone through all of the different connective tissue types. So to break it down real quick and easy, you have proper and special. Proper is broken into loose and dense. And each of these have 3 main types: areolar, there's areolar, there is a couple others. Look back in the rest of the PowerPoint, you know that they're there. And then in dense, we have irregular, regular, and elastic. And then our special ones, we've got bone, we've got cartilage, and we've got blood. It's reticular, that's what it was. And there's one more that I think starts with an A. But that's kind of the easy breezy breakdown. If you want to get a more in-depth breakdown, the slides just prior to these ones will help you out with that a lot. Okay? Cool. There's only one part left, so when you are ready, go ahead and move on to chapter 4, part 4.